Hello dear students, in 11th standard chemistry, unit number 3, the topic today we are going to discuss is effective nuclear charge. Okay students, dear students, when we study about this topic, when we study about effective nuclear charge, we must remember the structure of atom. You all know the structure of atom that we follow now. Okay, so can you please tell me about the structure of atom? Yes, very good. It contains a tiny positively charged nucleus, whereas the electrons will be revolving around the nucleus in a certain specified path, and those paths are called as orbit. அப்படிதானா எல்லா ஆட்டத்துலயும் ஒரு நியூக்ளியஸ் இருக்கும். அந்த நியூக்ளியஸை சுத்தி எலக்ட்ரான்ஸ் வந்து வட்ட பாதைகள்ல சுத்தி வரும். That is the structure of atom. Okay, okay. So do you know the nucleus of an atom contain what are the things? Yes, very good. The nucleus of every atom contains two subatomic particles. Those are protons and neutrons. Okay, so out of these two, protons and neutrons doesn't contribute anything for the charge of an atom since it is chargeless. Neutronக்கு எந்த ஒரு சார்ஜும் கிடையாது அப்படிங்கிறதுனால it won't contribute anything for the charge of an atom, so that the charge experienced by the nucleus is only the charge of the proton. அதாவது நியூக்ளியர்ல இருந்து கிடைக்கிற நியூக்ளியர் சார்ஜ் வந்து it is obtained from what? It's obtained from the proton. So that is normally termed as nuclear charge. ஒரு நியூக்ளியஸ்ல எவ்வளவு புரோட்டான்ஸ் இருக்குதோ அதை பொறுத்து நியூக்ளியர் சார்ஜ் அதிகமா இருக்குதா அல்லது கம்மியா இருக்குதா நம்ம சொல்லலாம். Okay, then what is called as effective nuclear charge? Nuclear charge and effective nuclear charge vary in which aspects? So that we have to see now. Nuclear chargeக்கும் effective nuclear chargeக்கும் என்ன difference அப்படின்னு பார்த்தோம்னா, so this is the structure of atom. It contains a nucleus and the electrons are revolving around the nucleus. Okay, so this is the nucleus and it is surrounded by a number of electrons. This is first shell and this is second shell. Okay, now we know that nucleus is positively charged because of the presence of protons, whereas the electrons are negatively charged. Okay, so this nucleus is giving out a certain amount of nuclear charge towards all the electrons. Its positive charge is spread through all the electrons, but the nuclear charge experienced by this inner electron will be higher than that of this outer electron. நியூக்ளியஸ்ல இருந்து கிடைக்கிற நியூக்ளியர் சார்ஜ் இந்த எலக்ட்ரானுக்கு அதிகமா கிடைக்கும், பட் இந்த எலக்ட்ரானுக்கு கம்மியா கிடைக்கும். அது ஏன் அப்படின்னா இட் இஸ் டியூ டு த ஷீல்டிங் ஆஃப் த இன்னர் எலக்ட்ரான். இந்த இன்னர் ஷெல்ல இருக்கிற எலக்ட்ரான் வந்து இங்க இருந்து வெளியில வர்ற நியூக்ளியர் சார்ஜை இதுக்கு கிடைக்க விடாம ஷீல்டு பண்றதுனால திஸ் இஸ் எக்ஸ்பீரியன்சிங் லெஸ் அமௌண்ட் ஆஃப் நியூக்ளியர் சார்ஜ் தேன் திஸ் இன்னர் எலக்ட்ரான். ஸோ திஸ் இஸ் கால்ட் as effective nuclear charge. Due to the shielding of the inner electrons, the valence electron experiences lesser nuclear charge. So the nuclear charge felt by this valence electron is called as effective nuclear charge. Okay, Mama, this is the definition. The net nuclear charge experienced by valence electrons in the outermost shell. அதுக்கு ஆக்சுவலா கிடைக்கும் இந்த லாஸ்ட் எலக்ட்ரானுக்கு ஆக்சுவலா கிடைக்க வேண்டிய நியூக்ளியர் சார்ஜை விட கம்மியா கிடைக்குது. So the net nuclear charge experienced by the valence electron in the outermost shell of an atom is termed as effective nuclear charge. Okay, Mama? Okay. And theoretically, it can be calculated using the formula ZEFF, that is equal to Z minus S. Okay, Mama? Using this formula, you can calculate the effective nuclear charge of whatever the electron is. Okay? Here, ZEFF means that is the effective nuclear charge. And Z is the atomic number, whereas S is the screening constant. Okay, what is ZEFF? It is the effective nuclear charge. In the former years, it was given Z star and ZEFF both are same. Okay, so ZEFF that is equal to Z minus S. Here Z is the atomic number, whereas S is the screening constant. So by using this formula, you can calculate the effective nuclear charge of the electron. Okay, Mama? Okay, and there are a number of rules given for calculating the effective nuclear charge. Those rules are called as Slater Rules. So let us discuss about the Slater Rules used for calculating the effective nuclear charge. Okay, okay. Okay, ma. Here I have given you the stepwise procedure for calculating the effective nuclear charge of a particular electron. There are 4 steps employed in the calculation of effective nuclear charge. Let us see them one by one. Okay, the step 1 as rule 1. Okay, it says that we have to write the electronic configuration of the atom for which you are going to calculate the effective nuclear charge. அதாவது நீ எந்த எலக்ட்ரானுக்கு effective nuclear charge கண்டுபிடிக்க போறியோ அந்த ஆட்டத்துடைய complete electronic configuration we have to write. That is the initial step involved in the calculation of effective nuclear charge. Writing the complete electronic configuration. Then the next thing we have to do is grouping. Out of the various orbitals, we have to group them. So the grouping will be as follows. The ns and np orbitals we have to place together. Okay, Vama? Okay. In the first orbit, we have only one orbital, that is 1s. So it forms a separate group. Then in the second orbit, we have 2 orbitals. Those are 2s and 2p orbitals. So it forms a separate group. Then in the third shell we have 3 orbitals. One is 3s, 3p and 3d. Okay, so out of 3s, 3p and 3d, s and p, that is the rule it's given, grouping ns and np together. So 3s and 3p forms a separate group, whereas 3d forms a separate group. Okay, then when we think about the fourth orbit, it has 4 orbitals. Those are 4s orbital, 4p orbital, 4d orbital and 4f orbital. Here 4s and 4p should be in a same group, whereas 4d separate group, 4f separate group. Okay, so this is the initial step for calculating the effective nuclear charge. What we have to do, we have to write the electronic configuration, then grouping should takes place. While grouping, we have to remember the s and p orbitals have to be placed together. Okay, okay, this step is over. Then let us see the step number 2. In step number 2, identify the group in which the electron of interest is present. Remember this word, student, electron of interest. It is nothing but, இது என்ன அப்படின்னா உனக்கு ப்ராப்ளம் கொடுப்பாங்க. Calculate the effective nuclear charge of the last electron present in the sodium atom. So எந்த எலக்ட்ரானை மென்ஷன் பண்ணி அதுக்கு effective nuclear charge கண்டுபிடிக்க சொல்றாங்களோ that electron is called as electron of interest. So அந்த electron of interest இந்த குரூப்ல எங்க இருக்கு நம்ம ஐடென்டிஃபை பண்ணணும். That is the step number 2. Identify the group in which the electron of interest is present. Okay, va? Okay. Then electron present in the right side. For example, பார்க்கலாம். Suppose you are writing the electronic configuration from 1s orbital, 1s2, 2s2, 2p6, 3s2, 3p6, 3d1. Like this you have an electronic configuration, and in the problem if you are asked to calculate the effective nuclear charge of the electron present in the 3p orbital, here in the right side of this 3p orbital we have 3d, 3d, 4s, 4p and so on. We need not to worry about these orbitals. இந்த நம்ம எந்த ஆர்பிட்டாலோட எலக்ட்ரான் கண்டுபிடிக்கிறோமோ அதுக்கு ரைட் சைடில் உள்ள ஆர்பிட்டால்ஸை we need not to consider. So that is given in the step number 2. Electron present in the right side does not contribute anything for the calculation of S value. Okay, then electrons in the nth group now, in this group the given electron is there, so it is called as nth group. Here we have 8 electrons. Out of 8 we have to take only 7. ஏன் 7 எடுக்கிறோம்னா for the last electron we are going to calculate the effective nuclear charge, so that we need not to include in the calculation of S value. So out of 8 we have to think only 7. So the remaining 7 electrons, that is the electrons in the nth group, is multiplied with the value 0.35 for calculating the S value. If the nth group is 1s orbital, நம்மளுடைய nth group வந்து 1s ஆக இருந்தால் instead of 0.35 we have to use the term 0.30. Okay, Vama, step number 2. In step number 2 what we are doing, identify the group in which the electron of interest is present. Then electron present in the right side does not contribute anything for the calculation of S value. Then electrons within the group is multiplied by the value 0.35. If the nth group is 1s orbital, instead of 0.35 we have to use the value 0.30. Okay, va? Okay, ma. Then let us see step number 3 and 4. Okay, students, step number 3 is very, very important. These values we have to memorize. But here there are 2 cases is given. என்னெல்லாம் அப்படின்னா if the electron of interest is in s or p orbital, நம்ம எந்த எலக்ட்ரானுக்கு effective nuclear charge கண்டுபிடிக்க போறோமோ if it is present either in s orbital or in p orbital, we have to follow this table. If the given electron is present in either d or f orbital, we need not to study these values because the contribution of s value will be 1. Okay, if the electron of interest is in s or p orbital, then the electrons in the nth shell are multiplied with the value 0.35. If the electron, then n minus 1th shell, அதுக்கு முந்தின shell உள்ள electrons we have to multiply with 0.85. Then remaining all the electrons are multiplied with the value 1.0, that is 1. ஓகேவா, இந்த மூணு ஞாபகம் வச்சுக்கோங்க. nth ஷெல்னா 0.35, n minus 1th ஷெல்னா 0.85. remaining all the electrons are multiplied by 1 only when the electron of interest is either in s orbital or in p orbital. ஓகேவா, if it is either in d or f orbital, no problem, we can multiply all the electrons by the value 1. Okay, then step number 4 is summation. இங்க நம்ம multiply பண்ணி கிடைச்ச values எல்லாம் we have to add to calculate the s value. So these are the 4 steps involved in the calculation of s value. What is the step 1? We have to write the electronic configuration and grouping should take place. Then in step 2, we have to identify the group in which the electron of interest is present. Then step 3, we have to multiply with these values 0.35, 0.85 and 1. Then step 4 is summation. Okay, dear students, now by applying the Slater rules, we are going to see a problem. Okay, so read the problem. Calculate the effective nuclear charge on 4s. This is very, very important. This we have used the term electron of interest. So enna ketirukanga 4s electron. This is called as electron of interest. So 4s electron in the scandium. Yes, see in the sense it is scandium atom. This is the problem. Calculate the effective nuclear charge on 4s electron in the scandium. Okay, let us solve step by step. Okay, what is step number 1? We have to write the electronic configuration. Okay, scandium's atomic number is 21. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Okay, so this is the way of writing the electronic configuration. Then grouping 1s separately, 2s 2p together, 3s 3p together, 3d separately, then 4s separately. Okay, so where the metal of interest? 4s. This is the metal of interest. Idhukku right side la indha electrons illa, so no problem. So step 1 is over. Okay, writing the electronic configuration and grouping is over. In step 2, identification. The electron of interest is in the 4s orbital and to its right side there is no more electrons, so no problem. Then we can come to step number 3, calculation of s value. Okay, mama? Okay, here which is nth shell? எங்க electron of interest இருக்குதோ எந்த ஷெல்ல உள்ள எலக்ட்ரானுக்கு நம்ம கண்டுபிடிக்கிறோமோ that is nth shell. So here 4s is the nth shell. அதுக்கு முன்னாடி உள்ள group வந்து n minus 1th shell. So here it is fully n minus 1th. Okay, it is nth shell, it is n minus 1th shell, then remaining fully no problem. Only we have to identify the nth shell and n minus 1th shell. Okay, இந்த டேபிள் ஞாபகம் இருக்குதா? nth shell உள்ள electrons என்ன பண்ணுவோம்? The number of electrons in the nth shell is multiplied by the value 0.35. Here we have 2 electrons and the 2ல 1 நம்ம விட்டுறணும். ஏன்னா அந்த ஒரு எலக்ட்ரானுக்கு தான் we are finding out the effective nuclear charge. Remaining we have 1 electron. So nth shell is 4s shell. It has 1 electron, so 1 into 0.35, that is equal to 0.35. Then n minus 1th shell, 2 plus 6, 8, 8 plus 1, 9. So 3s, 3p, 3d, 9 electrons, 9 into 0.85, that is equal to 7.65. Then remaining fully, 2 plus 2, 4, 4 plus 6, 10. So 10 into 1, that is equal to 10. Totally it is 18. Step number 4 is summation. We have found the sum of all these values. It's equal to 18. So we have found the s value. S is equal to 18. Now we can proceed for calculating the effective nuclear charge. What's the formula? ZEFF, that is equal to Z minus S. Okay, Z is the atomic number. The atomic number of scandium we have seen it is 21. 1. So 21 minus S value we have found 18. 21 minus 18, that is equal to 3. This is the effective nuclear charge of the electron in the 4s orbital. So the actual nuclear charge is 21. The 21 nuclear charge இருந்தாலும் கடைசியா உள்ள 4s எலக்ட்ரானுக்கு எவ்வளவுதான் கிடைக்குது? 3 charge தான் கிடைக்குது. Okay வாமா? Is it clear? First we have written the electronic configuration, then grouping, identification of electron of interest, then calculation of S value, calculation of effective nuclear charge. Okay va? Okay. One more example we can see using the same scandium atom. Okay, this is another example, but the same problem. Scandium atom, but orbital is changed. In the former case, it was 4s orbital, but now it is 3d orbital. Okay, the same way we can write the electronic configuration of scandium: 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Then grouping also have taken place. Now, which is the electron of interest? 3d is the electron of interest. இதுக்கு right sideல 4s இருக்குது. This won't contribute anything for the S value. So we need not to consider about the electron present in the 4s orbital. We have to consider only the electrons which are present before 3d orbital. Okay. Here which is nth shell? This is nth shell. And one more thing students, here the electron of interest is in d orbital. அப்ப என்ன பண்ணணும்? nth shell மட்டும் பார்த்துட்டு மிச்சம் எல்லாமே என்னதுதான்? We have to multiply by 1. Okay, in the nth shell we have only 1 electron, so no problem. Then remaining further inside 2, 4, 10, 12, 18. So 18 into 1, that is equal to 18. S value is equal to 18. Then calculation of effective nuclear charge, Z minus S. Z value is 21. So 21 minus 18, that is equal to 3. The same effective nuclear charge for 3d electron. The electron present in the 3d orbital. புரியுதாமா? First electronic configuration எழுதுறோம், அடுத்து grouping பண்றோம். இங்க 3d orbital எடுக்கிறதுனால அதுக்கு பின்னாடி உள்ள 4s நம்ம கன்சிடர் பண்ண மாட்டோம். This is nth shell. nth shell ஒரே ஒரு எலக்ட்ரான் தான் இருக்குது. இப்போ ரெண்டு இருந்தா கூட 2 minus 1 சொல்லி 1 எடுப்போம். பட் 1 இருக்கிறதுனால nth shell 0. 0 into 0.35, that is equal to 0. மிச்சம் இருக்கிற எல்லாமே நம்ம 1 தான் எடுப்போம். ஏன்னா இது d orbital. Okay, so 18 into 1, that is equal to 18. Appa S value is equal to 18. Then Z EFF, that is equal to Z minus S. So 21 minus 18, that is equal to 3. This is the effective nuclear charge of the electron in the 3d orbital. Okay, well, students, I think you may have a better understanding about effective nuclear charge. Okay, Mama, thank you.